Similar to vertical asymptotes, we can also have horizontal asymptotes and slant asymptotes that guide our function. That slant asymptote is just any other line that is not horizontal or vertical. Any other slope would be considered a slant asymptote. And where with vertical asymptotes, we can tell pretty easily with our function why it has that vertical asymptote, that x can't be that value and then it doesn't cancel. Horizontal is a little bit more something that we have to memorize the process of. Somebody else has found this out for us, and then just using that knowledge. The easiest way to remember it is using the acrostic Bobo Boatin eats DC. So if you have a way to remember that, or just memorizing Bobo Boatin eats DC, I always like to picture Bobo Boatin as a clown, and then, I don't know, maybe he's a Marvel fan or something, but he's eating DC. And what we're doing with this acrostic, they're representing if we compared the degree of the numerator to the degree of the denominator. So that's what we're looking at. We're looking at the highest power in the numerator, the highest power in the denominator. And if the highest power is bigger on bottom, so the degree of the denominator was larger, then we would have this horizontal asymptote at y equals 0. Remember, a horizontal line is a y equals, so this is the equation for the horizontal asymptote. If the power is bigger on top, so if the degree is larger in the numerator, then we won't have a horizontal asymptote, so Boatin, the N stands for none, but we could have a slant asymptote, so we'll come back to that. And then the last one, eats DC, says if the exponents are the same, because, it could be larger on bottom, it could be larger on the top. They could be the same. If it has the same degree on top and bottom, we will divide the coefficients that are in front of those terms of highest degree. Okay, so let's go through each one. So bigger on bottom, what that could look like, something like this, where we have a first degree in the numerator, second degree in the denominator. We would automatically say, okay, it's a Bobo, it's bigger on bottom, so our horizontal asymptote is at y equals 0. Same thing here. We've got higher power on the bottom, automatically, y equals 0. Same thing here, higher power in the denominator, automatically, y equals 0. So not a whole lot to it. Once you know the acronym, that is what it is. For our bigger on top, same situation, we're just not going to be able to have a conclusion just yet. So we have an exponent that's larger on the top, second degree in the top, and a first degree in the denominator. So it is bigger on top. We don't have a horizontal asymptote, but we'll come back to it because this guy does have a slant. Same thing here. We know that the exponent is bigger on top, or the degree is larger on top. Could have a slant asymptote. This one does. We'll come back to that, but it does not have a horizontal asymptote. And then the last one, our exponents being the same. So something like this, where we're noticing that we have a second degree in the numerator and second degree in the denominator. So that means we do have a horizontal asymptote and our exponents are the same. So we're dividing the coefficients that are in front of that term of highest degree. So in front of my x squareds, I have a 4 and a 3. So my horizontal asymptote would be y equals 4/3. Okay, same thing here. I've got my exponents are the same, first degree in the top and the bottom. So when I divide coefficients that are in front of my x to the first, I just have a 1 and a 1. So our horizontal asymptote is at y equals 1. Last one of these. We've got a 4th degree in the numerator and the denominator. Exponents are the same. Divide coefficients. We're using the coefficients in front of that x to the 4th, and so we would have y equals 2/5. Where they could trick you on this type of problem is if maybe they weren't in descending order. So be careful that you have the highest power that you're looking at the coefficients, or even just in deciding your Bobo Boatin eats DC, because if it's not in descending order and your x to the 4th is like over here, then you might miss it if you're just looking at the first term. So not always the first term, but look for that term of highest degree when we're comparing degrees. Okay, so back to our Boatins, because our Boatins did not have a horizontal asymptote, but they could have a slant, and the way that you can tell if it has a slant or not is that we already said it was a higher degree in the top, but our degree in the top has to be just 1 degree difference than the denominator. So a second degree and a first degree are 1 degree apart. You could have a fourth in the top and the third in the denominator, and that would work. If they're more than 1 degree apart, then you've got something else. We won't see any of that. But if they're 1 degree apart, that means we do have a slant asymptote. And the way that we find it is by synthetic division. So we are going to divide our denominator into our numerator, just like what it's saying here. This divided by x minus 2. Remember that you would have 2 in the box, and then we would have a 1, 7, and 5. And then the interesting part here is that no matter what the remainder is, I'm going to throw it out. So it really doesn't matter that we keep going. That last number is always the remainder. Our slant asymptote, remember we get knocked down a power, so since I had a quadratic to begin with, now I have something linear. So my line, my slant asymptote, is going to be the equation y equals a 1x plus 9. This is my slant asymptote. So what's happening here with the remainder is that technically we have this plus 23 over x minus 2, but that's such a detailed part of this, like you wouldn't be able to, if you're sketching a graph, that wouldn't make a difference. It's such a small detail that we go ahead and throw it out because this is really enough to say the slant asymptote is going to be y equals x plus 9. Okay, so same thing with this guy. We had already decided that he was a boson, so if he's bigger on top, then we're checking to see, okay, my degree in the top is 1 greater than my degree in the bottom, so that means I am going to have a slant. I'm using synthetic division. Be careful here, we do want a 0 at the end, but it's not really going to matter a whole lot because, like I said, we're going to throw out that remainder. So even if we get to this point, you know, sometimes it feels better to go ahead and finish something like this, but multiplying your -5 and -17, I'm like, I can't do that in my head really quickly, so I can just be done. I'm not going to have a remainder. So our slant asymptote will be at y equals a 3x minus 17. And that is my slant.